Another example from page 11 is problem number 3. You can see that the numerator already has just one denominator, so there is nothing to simplify or change in the numerator. However, the denominator is 4 over x minus 1, so that means I'm going to have to multiply the first fraction by x over x and the second fraction by x minus 1 over x minus 1. The numerator stayed the same. The denominator is now, of the bottom fraction, is x times x minus 1. That comes from here and here. They're now the same. But now the numerator is 4 times x, so it's 4x. And then 1 times x minus 1 makes it plus x minus 1. So I'm going to simplify that denominator before I do keep change flip. So 2 over x minus 1 the numerator, 5x minus 1 over x times x minus 1. And now I can do keep change flip. Keep the numerator the same. Change division to multiplication. And now multiply by the reciprocal. And so the reciprocal of the denominator is x times x minus 1 over 5x minus 1. X minus 1 cancels out, and so your final answer for number 3 is going to be 2 times x, that's this, over 5x minus 1. On page 12, we'll do 2 examples here. Rewrite each expression without denominators, meaning there should be no variable or number in the denominator. So I'm going to take this and I'm going to change it into 1, 2, 3, 4 different fractions. 5x over 5x to the third over x minus 4x squared over x plus 3x over x minus 2 over x. For the first 3 fractions, 5x cubed divided by x automatically gets rid of the denominator. Same thing with 4x squared divided by x, minus 4x. 3x divided by x is plus 3. The last fraction, you're going to get rid of the denominator by making the x to the positive 1 in the denominator be multiplied by the 2 already in the numerator times x to the negative 1. So that's the final answer for number 5. Number 8, rationalize or move the radical to the denominator. I think they mean move it to the numerator. So I think we're going to, well, rationalize actually means move it to the numerator, so we'll do that. So to get rid of a radical, I multiply it by itself because a radical squared frees what's inside the radical sign. So square root of x plus 1 times the square root of x plus 1 is x plus 1. And then x minus 1 times square root of x plus 1, you're basically just going to distribute the square root of x plus 1 so that it becomes x times square root of x plus 1 minus square root of x plus 1. So that's rationalizing the denominator because now it is no longer a radical. Last one, number 8. So it also says if your radical is in the numerator, move it to the denominator. So I'm going to have to multiply this by 1, and the 1 is going to be square root of x minus 1 minus 1. That's called the conjugate. And the reason it's 1 is because the fraction is both the same on the numerator, in the numerator and denominator. When I have this, it's almost like a binomial. I'm going to do FOIL. So square root of x minus 1 times the square root of x minus 1 is x minus 1. Square root of x minus 1 times negative 1 is minus square root of x minus 1. Positive 1 times square root of x minus 1 is positive square root of x plus 1. And then positive 1 times negative 1 is negative 1. In the denominator, you are basically going to do the distributive property again. X plus 1 times the square root of x minus 1. And then the same thing, x plus 1 times negative 1. So x plus 1 times square root of x minus 1. And then minus x plus 1. In the numerator, I'm going to simplify. I've got positive square root of x minus 1, negative square root of x minus 1, and then I have x minus 1 minus 1, so it's x minus 2 over. Either you can leave it the way it was before, or you can do it this way. I don't think anything will simplify, so if you want to leave it in factored form, you can leave the multiplier that you did up here as a factored form, x plus 1 times what I multiplied by. And even though that looks funky, that should be your final answer. Please finish all the problems on this page and the previous page before doing your homework. See you tomorrow.